And now, let's move on and talk about the data-driven information hub for sustainable urban mobility. I would like to give a virtual stage to Sadok Ben Yahia. Sadok is a professor at the Technology University of Tallinn since January 2019. He obtained his habilitation to lead research in computer sciences from the University of Montpellier in April 2009. His research interests mainly focus on combinatorial aspects in big data and their applications to different fields such as data mining, combinatorial analytics, and urban mobility in smart cities. For the supervision activities, he supervised 33 PhD computer science students and over 60 master students. He is currently a member of the steering committee of the International Conference on Concept Lattices and their applications, as well as the International French-spoken Conference on Knowledge Extractions and Management. Let's invite him on our virtual stage. Good day, Professor. Do you hear me well?
Yes, I do.
Amazing. It's an honor to have you here today, and I would like to give our virtual stage for your keynote presentation.
Okay, thank you very much. And I'm really happy that you invited me to join this event. So today, I would speak about congestion. So congestion is a major issue for cities. And we need to understand that congestion is a consequence from the massive adoption of vehicles or cars as main transport mode. It has negative effects on the daily life of the citizens. For example, it has the air pollution and also the augmentation of the carbon footprint, as well as social and psychological impacts, such as the increase of the anxiety, the stress, to cite but a few. In addition to that, he has an economic impact. So let's have a close look to this impact. For example, the American Transportation Research Institute estimates that congestion costs the US freight sector 74 billion annually. And if we have a closer look to our neighborhood in European cities, so we see that, for example, that Lodz is the top city in terms of its most traffic jam-prone city of Europe as per 2018. So I was able to find more fresh statistics. Moscow is the top city in percentage of extra time due to congestion in 2019. So I would say it's kind of plague, and it's clear that it is costing a lot of money to the European Commission, to the European states, and to the world at large. So what we are planning to do is to provide kind of solutions, element of solution to this congestion, how we can manage congestion in the cities. And we will see, we can run some experiments in different cities of Helsinki and Tallinn in Estonia. So the idea, what was suggesting you to proceed, I would kind of delve in your minds, and I would like ask questions on your behalf. So, and then I will provide the answer. So the first question that I would ask is, which urban challenge to address and what concrete aspect of it? So the tool that we'll present later, this dashboard, I would start by a dashboard. It's provide an open data platform for real-time monitoring of the traffic performance of cities. So what are the requirements, the desired requirements of? The first requirement would like that this tool would be immediate, has an immediate deployability. So what I mean by that? It means that we would like that next week, I would like to find it in the intersection nearby Taltek in Estonia. The second one, would like that would be data-driven, mean that would like, since you are storing data, the sensor data, and we would like that this data, the solution would not go idle. We would like to make money. We would like to take this knowledge nuggets from this data, do what we deduce later as sharp, accurate prediction. For during that, we will use this prediction during our taking decision process. We would like to take the decision in near real-time data. So there is this, what we call this zero delay feature. And we would like also to have this open possibility within that if you start with the initial set of sensors, we would like to even to open it, to extend it. In addition to that, we can also combine different types of sources. We would like to be able to combine sensor data, for example, speed, urban noise, CO, with radars, videos, satellite images, and so on. And we also would like to that our tools needs to be scalable. It means that since we would like to make it open to many connected or autonomous vehicles, the CAV, so it means that it is expecting that millions of CAV would be able to use or make use of this information hub or tool. In addition to that, since we are able to interact with traffic light controllers, it means that you can, in the big city, we have thousands of traffic light controllers. So that's we say that thousands of intersections. And in addition, the most important fact, which is kind of non-functional requirement, but is of utmost importance. So what is the point if you have the smartest system, the most sustainable system, if it is not resilient enough, if you are prone to a cybersecurity attack and all of your system will collapse. So it means that one of this required important thing is that your system should be resilient. Then this kind of requirements. So let's go to what we have already developed. So the second question is, what is the solution that you are proposing in this? So we would like to have this real-time dashboard for sustainable urban mobility that we call Open Sumoda. So basically, we are providing a reliable and scalable system for proactively steering the urban mobility. And I will stress on the fact what this proactively steering. So we would like to steer the urban mobility based on agreed on goals. So we would say that we would like in Tallinn to minimize or mitigate the urban noise. Or for example, in Vilnius, they would say, no, we would like to use our prediction would be driven by the reduction of the CO2 emission. In Riga, they would say, no, we would like to give higher priority for public transport. So in addition to that, we need to provide kind of adapted traffic light strategies that would like to use the cutting edge artificial intelligence, and very important that we can use this data fusion techniques since we have different types of sources. We have sensors, we have radars, we have satellite images, if any, and we have video. So we need to integrate all these sources to provide the most reliable data input in order to hope that we have the most reliable prediction. Then third question, how does the solution solve the main challenge that you are targeting? Actually, this Open Sumoda is using a reliable, what we call this hyper-local urban mobility. It's the kind of the sensor data that we are using. And you're also offering a real-time digital twin to convert the raw sensor data to a model of the traffic situation. Okay, so it means that the city stakeholders will be able to monitor what is really happening in the city. So let's now move to this to present in detail this tool. So it is phase 2. It is the almost line, though it means that I will give you kind of mouth-watering presentation of our tool, and you will understand later why it was phase 2. I mean that after this slide, it was phase 1, which is done under the hood in offline way. So as we are expecting, we have this extensible set of sources. So these sensors are providing us number of VI equals CO2, not CO2, CO2 emission level, urban noise, the number of vehicles, humidity, temperature, all the what would need. And we are providing kind of data integrated to integrate the different types of information. So, and you are sending to this Kafka. Oh God, what is Kafka? Kafka is, it's Apache Kafka actually. It is the most scalable event strategy platform, which is built on top of Apache Spark. So Apache Spark is the big data platform. Keep in mind that one of the requirement was that we need to ensure the scalability. So what is better than this most used big data platform, which is Apache Spark? And this, in addition to it, is open source. Later, what we have to do, so this Apache Kafka, it works as the model of producers and consumers. So it means that we have suppose that some agent which is producing, I mean, it is sending data to Kafka. And but this data, who is expected to be consumed by who? So this data, it is meant by what we call this our prediction engine, this deep learning or machine learning model that we built offline. So this prediction engine will consume the new data, the fresh data coming from the sensors, and he has to push back predictions. Prediction about what? It's about the agreed on. So if you agreed on that you would like to see the urban mobility with noise prediction, so it means that it will push back to Kafka noise prediction. If it would be CO2 emission, it will push back to Kafka prediction about the next levels or how we are doing. It means that in 15 and 30 minutes, what would be the levels of urban noise of CO2 emission. So this noise prediction, they are pushed back anonymously by Kafka. But who is consuming later this prediction? It will be our traffic light controllers. That's why I said we need to provide the scalability feature or requirement, since we have the traffic light controllers, they are working peacefully with the agreed on traffic light strategy. So, but they need to be all ears for kind of prediction which are provided. They need to go and to consult at regular pace. Do you have something what would be of interest? Yes, we would have kind of, it means that we are predicting that in 15 minutes, we have an increase in the urban noise, and consequently, you need to adapt your traffic light strategy in order to ease the congestion and in order to ease this congestion stroke. So later, so what he has is this traffic light, when he's consuming the noise prediction, he has to push back these KPIs. In that, for example, the KPIs, how many, the number of vehicles that have been given away, the number of, the quality of the urban noise, the CO2 emission, all the KPIs I will discuss later. So these KPIs, when they push it back to Kafka, we have kind of this Elasticsearch connector that would be connect and provide all the information to our dashboard. So this dashboard, we would like to make it not a silly one, kind of new generation of dashboard. We would like to provide to the city stakeholders a fresh information which makes sense. It would not like we need to provide knowledge. It means that if we are telling to the city stakeholders, oh, we are reducing with that amount of the CO2 emission, if we are reducing of that amount, it means that we have gain, we are providing the city. I will provide an example right later. A tangible example of what would be the gain if he's using this tool or this new strategy of traffic. So now if we step back, actually, I have already told you that the traffic light controllers are working peacefully. They are applying the anonymous and in autonomous manner. They are applying the best strategy that we are using to. But who would tell to them which strategy? So before, under the hood, we need to train. So a lot of machine learning or deep learning things that needs to be done in order to find which is the best strategy. So for example, the two strategies we have already developed in our team, one is more on the transport, and the other one, which is RL, which is more driven artificial intelligence, and more precisely this reinforcement learning. So now everything is fine. We would find what is kind of the schema of the best optimal schema for the traffic light management. So we know which one would fit for which time slot and which other algorithm would fit whenever we are predicting this spike of urban noise. So let's have kind of mouth-watering example. So this is one of the demos that we would like to provide to the city stakeholders. So by the way, if you are not knowledgeable in Tallinn, Tammsaare Supras is it's the name of the most known poet of Estonian one. And it is, in addition, one of the most congested intersections. So what we are showing here, this is the one of kind of snapshot that we are providing to the mayor, the city stakeholders. So these are the sensors of the green ones are the sensors. And what we are doing, we are saying that we're predicting a stroke. This is the red circle. The prediction that we have is a stroke. And as we can see, for example, that currently, the level of urban noise, we have the green part, and things start to be worsened in 15 minutes. So this is our prediction of the urban noise. And what we are providing to this, it means that we are telling him, until now, we are reducing the urban noise by 4.54%. We are reducing the fuel consumption of the cities, the cars, by 1.51%, which is not negligible at all. In addition to that, the average waiting time per car is lowered by 2 minutes, and we have less 3.1% of CO2 emission. In addition to that, we are saying to him, this kind of performance prediction, if you are choosing the CO2 emission as KPI, the main key performance indicator, so if the curve, the first one, it means that if you are staying idle, if you are doing nothing, this is the curve of the CO2 emission. But if you are using one of our two approach, we can see we are lowering for you the prediction of the CO2 emission. Okay, so the takeaway message of this slide that would like to provide really gainful information, something that motivates. It means that if you know that as a city stakeholders that you are reducing the urban noise, the CO2 emission, the fuel consumption with that amount, it means that it is providing you really very gainful information and tangible information. Okay, so let's go to the fourth questions, which is, but what was new in your existing solution respect to the to the pioneering ones of the state of the art. So our solution is providing kind of near real-time, adaptive, and proactive. So what is meant by proactive? It means that we are, since it is based on prediction, it means that we are predicting that we have an increase, a spike of urban noise, and consequently, we need to take the right decision, timely right decision, okay? And in addition to that, open SUMODA meets what we call this immediate deployability. It means that it is, if you have in your city sensor-driven information, we can use it. In addition to that, if it will be in 20 years ahead, it means that 20 years ahead, which is also with this military vehicles, when we have this, when connected and autonomous vehicles will be based on this protocol coming from the Internet of Vehicles, when vehicles can exchange information with what we call infrastructure, the traffic light control. So that we have vehicle to I as infrastructure. We can also, we have communication between vehicles to vehicles. That's why we have the model V to V. So that's why we have what we call this infrastructure-less settings. Okay, so it means that with this with VANET protocols, vehicle ad hoc networks. So it means that in that case, a vehicle can communicate its speed to the infrastructure, to the roadside units, to traffic light control, and so on and so on. So this is very important. I mean that OpenSUMODA, you can deploy it next week, as it can be also provide the right know-how to manage this. It is even easier to work with this V2X. The third feature is OpenSUMODA features kind of distinctive architecture by relying on the most known and reliable and used open source big data platform, which is Apache Spark, and the most usable even cement platform, Apache Kafka, for example, which is providing this high throughput and availability. And for example, if you see big companies from high tech, such as LinkedIn, Netflix, they are trusting and relying Apache Kafka. So, and last but not least, so OpenSUMODA offers this web-based dashboard, which is providing that information that speak and allows to steer the urban mobility performance. It means that they have update and fresh information. So, fifth question, what is the expected impact of the cities on the urban area? So it would provide more attractive and competitive public transport. In addition to that, we can able and assess through its impact through this KPI. So we have different types of KPI. It is kind of traffic fluency. So it can assess how much we are assessing, reducing the delays, the travel time stops, safety, environmental impact in terms of CO2, urban noise, etc. And last but not least, the economical point of view. So if you say that you are reducing the fuel consumption by this % and the time saving for doing the trips, so it's very important. So I will skip the demo that we had that we can show, but it is available in the slides in Helsinki. But from this demo, you will see the proof that this tool works in both in these cities. In addition to that, what would be the takeaway message of this demo? It is the importance of this extra information in this prediction. So what we can see that the best of the best in terms of performance on traffic light management strategy, it is the one which is based on reinforcement learning, unless you provide it with this prediction. It means that if you are providing on time ahead the traffic light control that, there is something happening soon in 15 minutes. So it means that we are adapting the strategy and it provides the best strategy. So, sorry if I will disappoint you if I'm telling you that this tool that we are providing is not this magic wand. Actually, we can, once as evaluator of this our project tells, we can never got rid of the congestion, and he was right. Why? This congestion is strongly connected, as I said when kicked off the presentation, that it is strongly connected to that we are, I would say, addicted to our cars. And why? So actually, its daily commute is reality for many. It's daily. But what is commuting? It means that if I live in Mustama in Tallinn, and going to Kaila, so I need to commute from one district from my place to my work and back. So what is clear that increasing the complexity in commuting patterns, so the harder for me to commute, the more is my car dependency. So when I'm taking my car, it means that I'm providing more problem, or more I'm worsening the issue of congestion. So, and we need to take to keep in mind something is very important, that we started looking at this kind of would like to understand where is rooted the congestion, where is rooted this daily commitment. I mean that let's back to the roots of the problem of the issue of congestion. If we understand, if we would like to remove the congestion, we need to tackle the daily commute. So we have this recent GRC technical report, which is really very recent. It is 2020, about the measuring congestion in different cities. So the use case that were given was this. It was in Sevilla, Brussels, and Krakow in Poland. And another pioneering work, which is owed to this colleagues from Australia, that we shall provide the concept of journey to work. So this journey to work, it means that it is based on census data and complex networks. And the idea that we would like to model the commuting activity from census data. So it means that we need to have data which is available, census data available too. So we would like to, so we are bringing this congestion problem to theoretical problem. So we would like to, this complex network measures like degrees, like strength, clustering coefficient, maximum clicks, average shortest path, which is very known by the notable in complex networks. It means that we are bringing them to the field, and instead of considering them as theoretical notions, we are using them. They are using them to explain and why we have this community. So it's very important if any city would like to tackle the issue of as kind of complement, as food complement. So the tool that we are presenting, that we would like to step back, would like to understand. So there is a theoretical work that needs to be carried out in order to have the insight. So I would quickly, I think that I'm behind the schedule. So as I promised you, I would like to show you how we are moving forward from simple dashboard to the city of Tallinn, for example, to an information hub by opening to its ecosystem. So here we are we have this my urban mobility. The sensor. This is what I'm presenting here. This was one based on Kafka. So, but I would like that this ecosystem, this information hub, would be accessible. That's why I call this open. It will be accessible by what we call this new generation of built-in vehicle dashboards. So in your vehicle, now this connecting vehicle, it is connecting to our information hub, and you would like to have travel time estimation, which is more accurate. I will present them respectively, recommendation of charging spots, and the recommendation of shared bike and scooters. So, but what is this? Why I have chosen 3 use cases? I will explain them. So, needless to say that it is very important to have an accurate travel time estimation. So, and we are providing, so it is always data-driven. So when you are able to access to this information hub, it means that you are able to access to all the prediction that you are able to do. So it means that you are able to accurately assess the time required for a given path, given spatial, temporal, and route conditions. So, and we have already published this pioneering work quite recently. After that, we would like to be able to the charging spot recommendation, but why? Actually, the production of the electric cars is more than double the 2020 compared to 2019, as would witness this plot. So it means that in your car, your car now, you will be able to get access to this charging spot. But what is happening? I have all the information in my app. So it means that from now on, once you set your destination, you would like to have, if you would like to have what is the charging spots, you need to step aside in your car, and you need to open your app, and you have to see which are the charging spots nearby. For example, in Tallinn, this information is not open, is not available in open portal. So it means that you need to go in ST Energia, you need to go to Elmorent, and you need to check which are nearby. But you do not have any guarantee that as far when you arrive to that charging spot, you can plug in your car, your charger immediately. That's why if you pay attention to what is, if you are going to this destination, the tool would provide you, you have 3 charging spots in the nearby, but we are recommending for you the green one, since based on our prediction and the historic availability, we are expecting that you have 85% chance to arrive there on that time, and that immediately you plug. So it's very important that you know that you are not spending all of your life in your car, and you need to open this built-in, this dashboards to the ecosystem. So in the same trend, would you like, upon arrival, that the tool would, is it possible to find this scooter or bicycle? But why actually we need to provide this information? So if you look to this plot, from 21-26, we have a growth rate of 6.8% in the use and the sharing of bicycle or scooters. So, and we are expecting an exponential development of the market is expected. So it means that my dashboard, my built-in dashboard, has to provide me prediction. It means he will able to tell me, upon arrival to your destination, you have 60 or 70% of chance to find nearby your destination bicycle that you can check. And it is really very recommended. It is sustainable and environmentally friendly urban traffic. So I would really to thank you, but before giving you back the floor, I would need to thank all the team that which is behind all these ideas and work, which is all PhDs and postdocs in time. So, and thank you.
Professor, thank you so much for such an inspiring and interesting presentation. When you're living in a city, you never actually think that such an easy thing as a traffic light can make such a huge impact on how we live.
Yes. Definitely, yes.
But I have a question from two parts. One part is after COVID pandemic, a lot of cities, they actually are trying to embrace the bicycles, the scooters, all other means of transportation. And will it still be a problem in the future when we speak also about the self-driving cars that will be able to communicate, right, among each other and to manage or to balance the traffic? And another question is, these kind of solutions that you were presenting, is it also applicable for huge mega cities that from some point of view sometimes it seems it's absolutely impossible to fix their traffic?
I would say yes and no.
Let's start from the yes.
Yes, it's a matter of scalability. It means that if you are the right big data platform, which is based on that we are not anymore able to have all the information centralized. We need to distribute. The more you have distributed. And for example, many of these high-tech companies are relying on, for example, LinkedIn. So terabytes of information daily, it is managed through, for example, this Apache Kafka. So it means the more you have reliable big data platform, you can manage. That's why we have the challenge. We would like to have millions of connected vehicles would be able to get the right predictions. And that we know with this 5G, it's the favored factor that would encourage. And what was the first question? Sorry.
The first thing is like cities are actually embracing other means of transportation. I mean, the bicycles, the scooters, will these kind of solutions be feasible? If everyone, okay, hypothetical situation, majority of the citizens are using bicycles and scooters. Do we still have same problems and we need this infrastructure?
Of course, yes. We will never be able to get rid of congestion. It means that if you have to deposit your son in the morning at his school, and then you take the older daughter to the secondary school, and then you need to be on time in your room office, it means that you cannot rely on the public transport to do so. So it means that, as I said, the harder the commuting, the more people are addicted to cars. But we really like to this, we have the feeling that we are doing harm to the nature, to the climate, and we need to fight the climate change. But it's harder than it. We need to arrive on time.
Absolutely. Okay, Professor, thank you so much for sharing such an interesting topic with us, and thank you so much for your answers. Good luck on your research. We actually want to see it also on Vilnius streets, if it's possible.
I would be grateful. So that's right. That I'm looking for real partners that would leverage all the shared experience together.
Okay, let's note this down. And once again, good luck. Ladies and gentlemen, that was Sadok Ben Yahia. He's a professor at the Technology University of Tallinn.